Hello and welcome back to InsightCM SDK training for 1.0. In this video we are going to be talking about how the SDK is used on a device, and this is where a majority of the programming happens, and so this is probably one of the more important videos in the series. Now, everything that I talk about in this video I will be demonstrating in the second half with the walkthrough, where I take a device and I use the SDK in LabVIEW to add that device to InsightCM. But we'll just spend a few minutes here in this video talking about the key concepts, and you will see all those concepts reinforced in the actual walkthrough. Now, before I get into that, I'm going to take a moment to review what an InsightCM device does. And this is kind of important and kind of not important. First of all, the SDK doesn't have the source code for the device, and so it's not really that relevant. But it's good to know that what the InsightCM device does, because that's really where we're coming from when we added the SDK features. So just briefly, let's go through this. For InsightCM, we have serios that are continually monitoring their data, but they only periodically send files. So the InsightCM device does not stream waveforms to the server, but it is continually monitoring data up to 102.4K, and it has a bunch of these default metrics: peak, crest, factor, true peak, gap, RMS, etc. And these are configurable. So for each channel you can have some or all or none of these being calculated for a channel. In addition to these waveform channels and metrics being continually calculated and acquired, we also have static channels that can be inserted into a couple slots. And these static channels are acquired once a second, and they are communicated as tags and evaluated against alarm conditions once a second. And in the device, there's some flexibility allowed for the number of dynamic modules and static modules, and that's why we have different flavors of each type, like we have the 8.0 and the 6.2 and the 08, etc., so to allow some flexibility in your I/O. And the key here is that the device can evaluate alarms off of any feature, any calculated feature from the waveform, or any static value. And again, that's happening once a second. And even though that's happening continually, files are generated periodically for at intervals down to a minute. When a feature enters or leaves an alarm state, that'll trigger a file. When a feature changes by a configured amount, that will also trigger a file. Or when a user presses a button, that can also trigger a file. When files are generated, they are automatically forwarded to the server. If the network is down, then files will be resent automatically. And I guess it's also good to know that each dynamic channel supports integration. Features can be generated off of each stage of integration, and so alarms can be set off of each feature off of each stage of integration. Now you'll see, now for a custom device, you will be defining all your own I/O, all of your own features. But you'll see some of these concepts in the SDK, and like files being resent and publishing tags, and it's good to know that a lot of that behavior was shaped by our InsightCM device itself. So it's kind of good to know where we're coming from. Now for the actual SDK, again, you're getting a library of VIs that allow you to securely connect to the server, retrieve its configuration, and publish tags, alarms, and files. And so this is a majority of the VIs right here. Over here on the left, this is where you're reading. If you recall from the last video, there were 5 configuration files, and one of them is not being used in the SDK. So we have an interface for reading the other 4 configuration files: your alarm rules, your connection info, your device model, which is called device configuration here, and then your equipment layout. Then in the middle here, we have our asynchronous processes. These are really the linchpins, the backbone of the running code that's in the SDK. The communication module is responsible for making the secure connection, and all commands go in and out of the communication module. Then we have the file manager, and his job is to handle stale files that are on the serio, Or if we attempted to send a file and it was unsuccessful for any reason, perhaps the network went down, then the file manager is responsible for trying to resend that file. And then finally we have our send message API. And recall, devices can send files, tags, alarms, and files. Well, we have an API here for tags, alarms, and files. So let's start here with the communication module. Again, this is the linchpin, the backbone. This is the heart of the SDK here. He handles all communication, authentication, file transfer, retrieval of configuration. All communication to and from the server goes through this VI. Now all messaging, now we're actually talking about LabVIEW here, any messages that come to and from this VI goes through a queued message handling API called QBus. And QBus is going to direct many of the architectural decisions we make in implementing the SDK, because there's a very good chance, if not 100% chance, that your application is not written in QBus. You probably have your own queued message handling API, either the ones that are used in the LabVIEW example projects or AMC or something else. But the SDK uses QBus, and so we have to get messages onto QBus and we have to read messages from QBus. So let's talk about the steps here to get authorized with the server. First, the communication module.vi will open up a TCP connection. And it gets that IP address and port from that file that we talked about in the connection info.json file that we talked about in the last video. It sends an authentication request based on this locally stored username and password. When it's authenticated, the device sends its local configuration version number. So it says, hey, my config file has this version number. Is that the latest? If it's not, and there's a newer one available, the server, again, the server owns this configuration, so he will send the new version of all the configuration files to the device. And this is very important here. The communication module.vi will then send this message on QBus called servercom.applyConfiguration. This is a signal to the application that new configuration has arrived. So you need to do whatever action it is you need to do to read this new configuration. I would say typically it just means you need to reboot your device. And when your device comes online, he'll then read the new configurations, if that's how it's built. But I think that's how I see most people implementing the response to this message. But the commod will give you this message saying new configuration has arrived. The application then closes and reopens its connection and applies the configuration. Like I said, it's likely a reboot. And once the version number on the device matches the server version, the device is authorized to send tags, files, and alarms to the device. Very good. So let's look at some LabVIEW here. And this will be more accurately defined and described whenever I do the walkthrough. But just on a conceptual high level here, I've got some slides that I want to just kind of start defining our approach of how we're going to integrate the SDK into our application. So I'm assuming here that we're starting with some existing application, a data logger of some type that you have already written. This data logger reads from configuration files, it already publishes data and logs to disk. Again, we don't have the source code in the SDK for our devices, so you need something. You'll need a data logger of some kind, and that is represented by this green square here in the middle. Now, we have at the very top our communication module, and he is going to try to send a message. And for instance, this apply configuration message, that's on QBus. Now we've got to somehow get that message, which is on QBus, into our application, which has its own messaging system, some queue or event structure or variable or like global variable, something that you use to message between all of your asynchronous processes in your application. So one approach that I would recommend is to insert some thread that reads messages from QBus and then resends them on your application's message bus. And what this does is it decouples your application from the SDK processes. It prevents you from having to read QBus inside your application, which can be kind of an invasive change. So I'm going to call this new thread a dispatcher, or the other word that I've heard for this concept is a broker, where you're taking messages from one message bus and you're putting those messages onto another message bus. So that's what we're going to do in our implementation for this video series. Was we're going to insert a thread called a dispatcher who listens to QBus messages and then resends them out. More specifically, we're going to be listening for servercom.apply configuration, and if we see that, we're going to forward that to the controller on his application bus. Then also at initialize, we're going to need the ability to read configuration from these 4 files and get that into our application. And really, this is the way we're going to merge this, is to have a VI which mutates the type definitions from the SDK into the type definitions that you're using in your application. And that'll take a little bit of work, but the idea is to leverage as much of the message bus and type defs that are in the application as you can to decouple the SDK from your application, and also to leverage as much of the work that has already been invested in the data logger. So that will be coming in future videos. Let's see, another very important message that you might get is something called active alarm IDs. If you're going to instantiate alarms on the device, then your device needs to be aware which alarms are active and which ones aren't. Because the device is responsible for setting alarms and then clearing those alarms, and so it has to maintain state. So one of the things the server will do is he will communicate the alarm states in a message called active alarm IDs. That will be on the QBus queue. Your dispatcher is going to receive that, but your alarm thread is really the one that needs that information. And so the dispatcher will take this active alarm IDs message, he will unpackage it, and then he will put that information onto the application bus into a message, and so therefore we can forward that into the alarm thread. The alternative to doing this would be to somehow put a QBus listen inside of your alarm thread, and that could be kind of an invasive change and kind of awkward, especially if you wanted to use your existing message bus, but then also add QBus, and you're kind of listening from 2 buses, and that can be kind of difficult to implement. This dispatcher or broker method is really a nice way to decouple these 2 message buses and move messages from the SDK into your application. Now, when it comes to sending messages, we can do one of 2 things. We can do that through the dispatcher as well, but sending messages, like putting QBus into your send, well, using QBus to send messages directly from your application threads is not that invasive. Like, all you have to do, you don't have to listen for anything. You just have to call these VIs and connect them to the QBus queue. So it's not so bad, like adding the type def for that queue to your thread, and then just calling these VIs directly from your application. That's not real invasive, and that's the approach that we're going to take in our walkthrough. So we'll have, like, at the top level thread would be like our data logging thread, and whenever he's done with his file, he'll call this VI called send file, which is supposed to transfer the file to the server. We can just put that directly in our data logging thread without it being too much of a hassle. Same thing with send alarm update. That can be in your alarm evaluation thread, and your send tag updates can be in whatever thread is calculating your metrics or looking at your device health. And again, he can just do this directly from the thread himself without it being too invasive. Or the other way is to stay true to this decoupling method and have application messages being sent to the dispatcher or a second dispatcher, and then we can just keep all the Insight SDK VIs inside of there. That's the other way to do it. And in fact, if your application's not written in LabVIEW, you're going to have to do this. But if it is written in LabVIEW, then it's really kind of easier to put them just directly in your threads.